Docker is one of the essential tools that everyone should know. And that includes developers, operations, QA. It's really useful for everyone, and that's where we are moving towards. We are moving towards a world where we are using a container-based delivery system. The software delivery is being transformed with the whole containers and container orchestration engines come into play. And Docker is something that you should definitely know about. Now, in this section, you're gonna get started with just enough Docker. And that's going to give you an ability to understand the most basic concepts related to Docker. So let's have a look at what you're going to learn in this section. In this section, you're going to learn how to set up an environment to run Docker. You'll also learn how to launch your first container, how do you operate it, how do you publish an application and access it using port mapping, also using a UI-based tool to manage container installation. You'll also learn how to launch a microservices application with interconnected services. And finally, how do you Dockerize your application and convert it into a Docker image and publish it to the registry that is Docker Hub. All right, sounds exciting? Let's get started with that. And the way you're going to follow this series is you watch the video and along with that, you try to follow along. You have already set up the environment. You should be able to follow along. Pause the videos whenever needed because these are like really crisp, compressed versions of the video. It takes really a 10-minute video takes about a couple of hours of work, and then we compress it, we record it, and we'll do a voiceover. So it is really fast. So if you are not able to follow, it's too fast, stop it, pause it, slow it down. Make sure you understand the concept, make sure you actually implement it. If there are any projects at the end of it, do those projects so that you understand this really well by actually doing it. So this is a hands-on section. So I'm going to show the demonstrations, you're going to follow along, and then you're going to learn by actually doing it, right? And that's how you basically follow this section. Good luck with learning Docker.
Hello there. Welcome to the course. This is Kian from School of DevOps, and I am here to introduce you to your instructor, Gaurav Shah. Gaurav is a leading DevOps coach, a corporate trainer, an author, a speaker, and a consultant. He started his career as a ops guy, moving his way up to head the ops team. He then successfully launched a DevOps consulting firm, and then went to become a DevOps coach as well. Touching all aspects of the profession puts Gaurav in a unique position to preach about DevOps. While still doing consulting, Gaurav forayed into corporate trainings, and quickly became one of the most sought-after DevOps trainers. He has trained professionals from some of the top companies of the world including Cisco, Walmart Labs, Visa, Intuit, Mercedes-Benz, DreamWorks, Expedia, Qualcomm, Schneider, Citrix. And the list goes on. All these pictures are sufficient to narrate his story as a corporate trainer and a public speaker. Gaurav has authored a book on one of the leading DevOps technologies, titled Ansible Playbook Essentials, which was published in the August of 2015 by Pact Publications, UK. As a course author, Gaurav has more than 60,000 students, including 35,000 plus on Udemy, who come from 160 countries, speaking more than 40 languages. In addition to that, he has 5,000 plus students on School of DevOps platform, 5,000 plus on edX, 10,000 odd corporate professionals, and thousands on many other platforms including O'Reilly's Safari Books Online, Pact Publications, etc. On Quora, Gaurav actively answers questions on the topic of DevOps, and his answers already have more than 600,000 views. Recently, his 30 Days DevOps Challenge course has been featured in the Ultimate Tech Career Toolbox 2020, along with 26 other top-notch course authors from across the globe. He was the only one to be included on the topic of DevOps, and the only course creator from India to be featured in this bundle. Gaurav has authored courses for Linux Foundation, the organization which owns and drives some of the most popular open source projects including Kubernetes, Jenkins, and even Linux itself. One of his courses is even published on edX, the leading platform which hosts courses only from either the top universities or the most respected organizations. In addition to his passion for technology, his drive to share the knowledge with the world, and his ability to simplify complex concepts, what makes his courses unique are his constant effort to incorporate cutting-edge educational technologies. Some of which include the Lightboard Studio, iPad-based whiteboard lessons, use of professional-grade audio-visual gear, all of which makes up an engaging learning experience, as well as result in high production value. You have made a perfect decision by signing up to this course. With this, you are getting a distilled learning experience from someone who has taken about 18 years of his professional experience to create a concentrated, step-by-step, learning path for you. Cheers! And all the best with your DevOps journey.
In order to use Docker, you need an environment. Now, I'm not going to practically show you how to set up an environment, but point you to the documentation, which is docs.docker.com, and this contains detailed documentation on how to install Docker on various systems. And you have a choice between Docker CE and Docker EE. Docker CE is the community edition, and that's what I'm going to show you in my demonstration. So if you click on Docker CE there, you have instructions for almost every single operating system, including different distributions of Linux, which include CentOS, Debian, Fedora, Ubuntu, etc. You also have instructions for Mac OS and Windows, where you have a couple of options to install it, as well as it has instructions for setting up Docker on the cloud environment, which includes AWS and Azure. This is just a sample instructions manual for installing Docker on CentOS using a repository where you install prerequisite packages, set up repository, install Docker, and then validate using one command, that is docker run hello world. You have similar instructions for different operating system from the documentation. So if you want to install Docker, docs.docker.com is your friend. If you do not have a way to install it locally or even remote server, you can also use this portal called as play-with-docker.com. Here you will have to log in with your Docker Hub ID. So you should create a Docker ID or GitHub ID. And once you log in, you can add an instance which gives you a working Docker environment. And this is completely out of the browser. So you do not have to install anything, or you don't have to provision any server whatsoever. This is the quickest way to get started with Docker. And I just validated that using Docker version. I have an environment with Docker running. You can also do the smoke test using docker run hello-world command. That pulls an image and launches an application, and that's the sample application that you can see there. If you want to validate your installation, generally use these commands. Docker version, it shows you the version of client as well as the server. If you see both client and server, your Docker installation is absolutely okay. If you don't see server, there's definitely a problem with some installation steps. This also shows you the version of Docker, which is 18.06. This is the latest at the time of creating this video. This is 2018. 06 stands for June, so it explicitly mentions when this version was created. And if you want to do the smoke test, you generally run docker run hello world. This actually pulls an image. So if you have internet connection, it will show you some issues. It has run an application. So this just validates that your daemon has been running correctly. You do not have any network connectivity issues either. And you are able to run an application using docker run command. You also need an access to Docker Hub. Docker Hub is a registry where you will find a bunch of images. Images are self-sufficient application packaged along with its dependencies, including the operating system files as well. For example, this is an image for Jenkins, and a lot of images also will show you the instructions on how to run that and launch a container using that image. As part of this section, I'm going to show you how to launch an image and an application using this image rather, and using some of these tags. Tags represent the version of the image, typically which maps to the version of the application as well. Now this is the environment that I'm going to use. This is the remote server that I'm running on Ubuntu with Ubuntu operating system. And when I run docker system info, it shows me the information about Docker daemon. How many containers I have, how many are running, how many are paused, how many images I'm running, which is the storage driver that is overlay 2, that's part of the overlay file system. The runtime is runc, so Docker uses runc internally, and it also shows me a lot of other information, including which operating system, what is the CPU capacity, the total memory available on my system where the Docker daemon or Docker engine is running. Again, I would run Docker version and Docker -v. Docker version shows you both client and server versus Docker -v only shows you the Docker client version, nothing else. And if you just run Docker, it shows you the help where you will find all the sub commands related to Docker. Earlier, you had only these commands or flat commands, sub commands where you could run containers directly. Now we have categories of sub commands here. That's because Docker has added a lot of functionality and there's only one Docker binary. Now we have categories such as for containers, for images, for networks, for volumes, some related to the Docker Swarm, which is orchestration engine. So you could either use Docker container run or Docker run both. I mean, it is backward compatible, so you can use any of these commands. So that just validates the environment. So I'm all set to get started running containers. And this is my environment running on a remote server, which runs on top of Ubuntu on DigitalOcean platform. Now that I have environment ready, I'm going to start running my first container. And that just validates my environment again. Now to run my first container, I need an image, and that's where the registry is needed. And I'm going to use the public registry, that is Docker Hub. On Docker Hub, if I just click on explore, it shows me a bunch of images which are available. I'm going to pick a basic operating system image that is for Alpine. Now Alpine is a distribution of Linux, just like Ubuntu and CentOS and OpenSUSE. But the reason why I'm choosing that is because of the footprint. So if you look at the image size, it is in MBs, and that is like in 2 or 3 or 4 MBs. So that's really a tiny operating system based on BusyBox Linux. And that is really good for smoke testing and running smaller images just to test containers, right? Now, when you run a container, this is important. You have to define which application that you want to run, application or a command. So we are using Docker to run a container. And the purpose of running a container is to launch that uptime as a command. And that command comes from the image, which is Alpine, and the tag that I choose. So if you look at the image has 4 different formats or 4 fields. One is the registry. Registry is this Docker Hub. Docker Hub is where all my images are hosted. So that's the first part. And then comes the namespace and the image. So image contains, just like GitHub, it contains username / the repository here. So username is a namespace, and it can be username, organization name, or a project name depending on how you have configured it. And then comes the repository : tag. Tag is typically, so this is a registry. Each of this is a registry, and the username. So if you look at the namespace, this image does not have the username, that is official image from Docker Hub. So you can omit the namespace. It's called as a root namespace. And tag is nothing but the version of the image. So you can create different images. This is a repository of images. It's not one image, but it is a repository. So the mandatory field here is the repository. Everything else is optional, because if you don't use registry, it will take Docker Hub. If you don't use namespace, it will assume root. If you don't use tag, it will assume latest. So the only thing which is mandatory is the repository, which is Alpine. That's what I'm defining here. So I'm using Docker to run a container with Alpine, let's say version 3.6, and to run a command uptime. That's the purpose. The purpose of running this container is to run uptime. That's something you need to start understanding, and that is different than running a VM. I'm going to just split this screen into 2 so that I can show you what happens in the background when you run that. If you want to see the events, you can run Docker system command. So Docker system info we have seen this already. Docker system events show you or stream the events. So whenever you run a command, it will show you what is happening what events are happening on the backend Docker daemon. So I'm going to run a similar command, docker container run alpine. This time I'm not going to define the tag. So since I omit the tag, it is going to pull the latest version of the image, and I'm running a command called as ps. So if you look at the output, it says unable to find image, and then it starts pulling it from library that is Docker Hub, and it has run that application. Now if I run docker ps, it doesn't show me that container being run. So what happened to my container? If I run docker ps -l, it shows me the container, but it is in exited status. So I see the image, the command, when was it created, it immediately was exited. And this is important. There's an important aspect towards Docker, is that we've seen these events happening in the Docker system events. And this is important, that Docker will be alive. Docker will run the container until the application inside it is running. Since the ps and uptime commands were one-off commands and not a persistent application, Docker exited immediately after launching the container and running that command. That's the reason why you don't see it anymore. And you can try running those commands, like one-off commands. I'm trying to create, so each one of these instruction is creating a container. You can see that in the Docker system events. For each of that, it is creating a container, and then that container starts and then dies, it is in the stopped state. It's not been removed, but it's in the stopped state. You can list it using docker ps -l will show you last run container, -n, and the number will show you last x number of containers. Let's say in this case 2. If you use -a, it lists all the containers running. These are really helpful commands, and this is an example of running or getting started running the containers, and these have been ephemeral containers so far. In the next video, I'm going to show you how to launch and persist a container. The containers that I've created so far have all been ephemeral. I've not been able to see what's inside the container. How does it look and feel like? So I'm going to start the container with new option, which gives me ability to interact with that container. And the options that I'm going to choose this time are -i and -t. So you can combine that using -it as well. And I'm going to use docker container run -it, the image name. I'm going to use the same image, and if I use -it, it gives me a standard in and ability to interact, and I need to open a shell. It can be sh, it can be bash, it can be zsh, whatever is available inside. Now it launched the container. This time I don't see the die event because it started the container and just resized, which means the container is still running. And in fact, in the top screen, I'm connected to the shell of that container. I'm going to run docker ps and watch it. So I'll use a Unix utility called as watch to examine what is happening inside it later. And if I go inside the container, I see that it's running with Alpine Linux. So this is what a namespaced container looks like, because on top I see Alpine Linux. The bottom is the host which is running this container, which is still Ubuntu. And I see so many processes on that host, but inside the container, I only see the process that I launched, that is shell. This is the difference. This is how namespaced containers look like. So even though it is an application running in an isolated environment on the same host, that's my footprint of the container on the actual host. It is actually running a process on the host, but inside that it gives me its own PIDs, and it gives me its own IPC and the process namespace. It also has the network namespace, which gives me the interface, which is ETH0, and an IP address that actually maps to a virtual interface on my underlying host, that is my Docker host on which this container is running. So that ETH0 has a mapping with v8 interface. This is called as v8 pair, and this is also the example of a network namespace. So I'm using watch command, watch with docker ps, which shows me what is running currently. So the moment I exit from the container using control D or exit command, that container just exited. That's what I see here. Now what I've been using so far is just shell with Alpine, but I'm going to launch an actual application and show you what happens. And if I want to run a long running persistent container, I have to use that -d option as well. -d, if you look at the difference, earlier it opened a shell and I was connected to it. -d detached from that so that I can run the commands on, I can come back to the shell and run it, and the container still is running. So if you look at the bottom part, monitoring console, it is still running. Now I'm going to launch another application using this image, School of DevOps / loop, which has an application called as program. Now this pulls the image and it is going to start running a container. I am not using -d option. I'm just using -i and t. What I'm showing you is what happens if you use -d and what, if you don't use -d. This is exactly what happens. The Docker is attached to the application and I cannot come back to the shell unless I use Control P and Control Q. So if I use -it, I still can detach from that using Control P followed by Control Q. That's what I did. But if I use -d, it not only launches my application, but also immediately detaches from it. If I don't use -i and t, I cannot even detach from that application. It is connected to the application. If I use Control P, Control Q, the exit escape sequence, it doesn't work. I have to use Control C, which kills the container. I can show you that. If I list last two containers, I see that the one I started with -i and t is still running because I could gracefully detach from it. The one which I did not start with -i and t, I had to kill, so it is not running anymore. So using these three options, -i, -t and -d is always useful. That will launch a container, run it persistently, and it will allow you to run next commands because it has detached from that container. And those are the options that you should definitely start using: -i, d and t to make containers persist. Now that we have launched the containers, let's look at some of the essential operations that we could do on these containers. Now, the first thing that you do is list the containers. And to list the containers, we've already seen this command, that is docker ps. And when you look at docker ps, you see, if you want to identify those containers, refer to those containers, you can use either the ID, that is the first column, or the last column, which is a name, or you can also use a glob from that first container ID. Now the first thing that we're going to do is rename a containers. So if you look at the names, those are like some funny names which are in the last column. You can always rename that container using docker rename command. Provide the existing name and the new name. So now my container has been renamed to loop. Now I can also refer to this container using this container ID or a glob, which is unique, either the first two characters or the first three characters. That's what I commonly use. Let's say docker logs and A78 refers to my first container, which starts from A78. Now the second operation that we are doing is checking the logs, and that is using docker logs command, or you can tail a log using docker logs and the container ID -f. This is constantly updating the logs for me. The next command, which is really important, is using docker exec. Docker exec allows you to run commands inside a container. If you just use exec command, container ID and the command name, let's say ps or uptime, it opens up an exec shell. That's what you see on in the bottom part where I'm streaming the events. It opens up a shell, starts running the running that exec, and then disconnects it from it. Now, if you want to have a persistent connection, if you want to create, let's say, since Docker is not running SSH or anything else, if you want to log into Docker container, you also used exec command, but with -it option, and then provide a shell that you want to open inside a container. This opens a persistent shell inside the container, and this is similar to running SSH connection to a running server. Instead, in Docker we use docker exec -it, container ID, and the shell. Do remember that command: exec -it and container ID and shell. And once you're inside the container, you can run anything related to that containers that containers operating system supports. In this case, it is the Alpine container, so I'm using some apk commands. I just installed vim using apk add vim, and then I can list process, do some debugging. And these two commands, logs and exec, are really essential for essential operations on that you may want to do regularly on a container. You could also use docker inspect command. Docker inspect gives you detailed information about that container, and this starts from the program or the application that your container runs, to the image, to the log path, if you look at the log path, for example, this is created a JSON file, and if you go to the Docker host, this is Docker host, not on your laptop, but on the Docker host, you can also see or examine that log. If you want to find out where the log is, that's how you find it, using Docker inspect. Apart from that, it also shows you if you have put any limits and any configuration, any mount paths, volumes, anything else that you have on that container. You can examine that using Docker inspect command. Now, the next operation that we're going to look at is copying the file. And to do that, I'm going to use Docker CP or Docker Container CP. Both will work because Docker Container is backward compatible, the new utility that is. So I'm creating a local file using touch utility. That's a test file is what I'm going to copy inside the container. So to copy that inside a container, I need the container name or the ID. When you reference a container, it can be name, ID, or the short glob of that container ID. So it just copied to, Docker, that stupefied Newman opt directory. I can also see what has been changed on the container using Docker diff. This is similar to git diff. So whatever has been changed or added after the container was created, you can use Docker diff to see that. Docker stop takes one or more container IDs, space separated, and it sends a sig term, that is signal 15, waits for 10 seconds. If the container does not stop, it will send the signal 9, that is kill signal. So you could also use Docker RM on these containers which have been stopped. If the container has been stopped, you can use RM directly. If you want to run Docker RM on a running container, let's find out what happens here. So Docker RM, I'm going to use Docker RM on the containers which are currently running that I have listed using Docker PS. You cannot directly remove a container unless you use the force option, that is -F. So if you want to stop the container and remove it immediately, we use Docker RM -F. And those are some of the essential operations that you should be aware of. Most importantly, Docker logs, Docker exec. I've started running and operating the containers. Now it's time to access that application from outside. And to do that, I'm going to launch a container with a web server image. So I choose the Nginx image from Docker Hub. That's Docker Hub Explorer, and it shows me the Nginx as the first image. And I'm going to pick the latest version of Nginx is what I'm going to launch. I already know how to run a container, so I'm going to start using those common options, Docker container run -idt, and then the image name. If I don't provide the tag, it assumes latest. So I can either provide -latest or :latest, or I can just omit that. The command is automatically taken from the image. So when you build an image, you can also define the command that can be launched, which I'm going to show you in a later stage when you build a Docker file as well. So if you look at the Docker file here, and if you scroll down at the bottom, generally it has the command defined, and this is the command which is going to be launched automatically. And since it has been defined as part of the image metadata, I don't have to provide the command either, but I need another option that is -P. Remember, it's capital P, and we'll just see what happens when you use that capital P option. This is pulling the image for Nginx, which is a web server, and Nginx typically runs on port 80, and it has started running that application, and I see all the common output. Along with that, I have this new option that I see which shows me some 32769 pointing to 80. 80, I know that it should be in Nginx port. But what is that 32769 is, this is how the Docker works. So Docker is running inside my Docker host. That container is running that inside that host. The container is running on port 80. And from inside, I can access it from 80. But if I want to access it from outside, either using a browser or even my laptop where I'm running container inside a VM, I can reach out to that VM or the Docker host, but not to the container. To access that, you have to map that port, and that's what has happened here. So that 32768 or 32769 is the port that Docker has picked up automatically. Docker has some default mechanism. So when I use capital P, it automatically knows, it reads the port from my image, and it points it has pointed 32769 from my host, which is a Linux server running remotely, this is the IP of my host, to that container. So I'm going to access it using the combination of my host : mapped port, not the container port, the left-hand side port. So if I go to 32769, I land on that Nginx containers web page. And that is that port mapping all about. Now, if I run more than once that same command, it would launch, every time I use docker run, it launches a new container. And since I'm using capital P, it automatically increments the port number. So not only I have 32769, but now I also have 32770 and 771, which is pointing to the new containers respectively that I am running here. This is how the port mapping works, and the IP address depends on your environment. So if you're using Docker for Mac or Docker for Windows, you use localhost. If you are using, let's say, Docker Toolbox, the IP address will change to your VM's IP, which is typically 192.168.99.100 or 99.101. So according to your environment, that IP address and the port mapping and the IP address, the URL will change. You can also define a specific port. So if you want to point, let's say, port 8888 to 80, instead of that automatically generated port number, you can use small p. Left hand side is the host port, right hand side is the container port. So now my hosts 8888 is also pointing to the newly created containers 80 port. That's another Nginx running right there. And just like this, you can actually launch any application using the information that you have learned so far. I'm going to show you running an application. It's a web-based, publishing platform, an application called as Ghost. It is similar to WordPress. It's a content management system, created using Node. Now, if you want to run an application, just search for an image and you should be able to launch it with any of these tags. You can use the default commands, docker container run -idt capital P and the image ID. A lot of times you'll also see in the documentation the instructions to run that container. That's what I'm going to rely on, and it is very similar to what we typically use. And it has few additional options. Now this is missing -int, so it is always safe to add those options. I generally use that -idt combination, and I recommend that. I added a name to be Ghost. I changed the name to Ghost, and this is using a port mapping which is 3001 to 2368. And I'm going to just customize that image. I'm going to pick an image called as with the tag Alpine. And that's all you would need. So, and similarly, you should be able to launch any application from Docker Hub using a combination of commands similar to this or something on these lines. So it is pulling the image, it is going to launch the application. If I run docker ps-l, it shows me the last run container, which is this Ghost application. And it has done the port mapping, so the same IP, but host IP, that is docker host IP, :port 3001 should show me that it is running on, it should be running. I just use docker logs command to find out whether that application has started or not, which has. So if I just point to 3001, this is my application, and it just takes few minutes or even less than a minute a lot of times to launch an application. That is just amazing. You can actually run any application, anything that you want. You never have to worry about installing that application, or because Docker gives you the complete package which is self-sufficient with the application, all dependencies, including the file system. You could also use docker stop to stop a running container. So if you've launched an application, you want to work with it later as well, you can stop it, you can start it. I just see that in a stopped state, and I can start the same container using the start command. You don't have to use run commands again. So don't use run command, because it will launch a new container and you might not see the data, and you might think that Docker is just ephemeral and my data is lost. It's not the case. You can start the same container using docker start, either the container ID or the name. And before I did that, I just showed you that it's been stopped, and if I started back again, now it is running. So if I go back to the browser and reload, I have the application with the same state that I had stopped it with. This is how you can run the containers. So you should be able to, using these commands and the information and the port mapping, go ahead and try out running some containers or the applications from Docker Hub. If you have been using VMs to create local development environments, here is the good news for you. You can actually easily do that using Docker containers as well. So instead of using VMs, which would take time as well as it will consume a lot of resources, you could simply create the containers, and that's what I'm going to show you in this video. Now, if you list images using Docker images or Docker image ls, it shows you all the images. If you want to find out the layers of that image, you can also use Docker history command or Docker image history command and the container or the image ID and this shows you all the layers. This sort of reflects the layering concept and the overlay FS that Docker uses. Now, coming back to our point, if you want to use Docker as a development environment, let's say I'm going to create a dev environment using Ubuntu and CentOS. You can directly run a container which pulls the image anyways, but you can explicitly pull the images using Docker pull commands as well. And I'm pulling two images, one Ubuntu and second is CentOS, and all the latest versions of both. And I'm going to create two different environments using these images, and it would take less than a minute to set up an environment. And that's what I'm going to do here. So I have the images ready and pulled Ubuntu and CentOS. I'm going to launch a dev environment with Ubuntu first. So I use Docker container run -idt. Those are the common options, and just provide a name to this container, that is dev-ubuntu. This is a name that you can decide. Now, either you can define the port. If you know that, I'm going to run an application on a particular port, you can define that in advance. If you're not sure, you can also use host networking, which will allow container connect to the host directly and run any application on any port. You'll have to take care of port conflicts though. And then I'm not sure what I want to run, so I just started it with bash. That gives me a flexibility. That is like running a VM with the default OS, vanilla OS. And then I can connect and start making changes to it. Similarly, I just created a CentOS environment as well. I see both of those are running. Now, if I want to make changes to this dev environment, which I created with Ubuntu, I could simply log into it using exec command. So exec-it, the container ID or the name, and bash. Now I'm inside that container which is running bash, and then I can run any command, including installing any packages with apt utility or making any changes. Let's say I'm going to install an application that is Vim and start editing and making changes to it. I'm going to add one more file called as my file as well. What I want to show is this environment persists even the restarts or even your system restarts. So even though Docker images or Docker deployments on Kubernetes, etc. are immutable, you can persist the data across your restart, make changes, use it as a dev environment as well. So I just stopped that, and I'm going to start it back again and show you that the changes that I have made are still there. So if I start it back and exec to that container, I still see my file that I created. So if you created any data, installed any packages, it would still persist the restart, even the restart of the underlying system where you're running Docker container in. Similarly, I have another environment with CentOS. I can connect to that again using the container ID and open a bash. Both of these images have bash shell, which is good. So I can start using yum install instead here, and then start development on the CentOS operating system. And once I'm done, I can stop those containers again. If you want to use it again, you can start it back. If you want to delete it finally when you're done with this dev environment, and if you want to clean it up, you can use docker rm followed by the stop command followed by the docker rm rather. So when you use docker rm, it is going to delete it. This is the time it deletes everything. So if you want to persist some data, you can commit and take a snapshot of that, or you can just delete it if you're done with that environment. That is how you use your containers as dev environments. By now you know how to run a container, how do you launch it from a Docker Hub image, as well as how do you connect to that container using the port mapping. What I'm going to show you is a very interesting application which will allow you to run a web-based application which manages your local or even remote Docker environment. So instead of using Docker CLI, you can completely rely on this web application, and that's what this application called as Portainer is. To set up Portainer, all you do is go to portainer.io, go to get Portainer, and run these two commands. One of that creates a volume which will persist the data which is generated by Portainer. Second, runs the Portainer, launches it on 9000 port, you know the port mapping, and then it does some special setup where it will mount the socket on the host inside the container, which will allow my container to connect to the Docker daemon and manage it on its own. That's what gives us the privileged access. And it is running on port 9000, so I can go to the host, call in port 9000, and that opens up the Portainer setup page. Now this is where I have to create the password. It's not a predefined password, so don't go looking for the password. You generate a password here, which should be at least 8 characters long, and then you connect to your Docker daemon, either local or remote, or you can also use a Portainer agent or launch it on Azure. I'm gonna use local, which is why I had actually set up that -v option. If you don't have that -v option, you'll have to go back and redo it again. This is the Portainer page, and it is already been set up. That is really amazing, and I didn't have to worry about how to launch, how to install Portainer. It is just a Docker image which I launched as a container, and I have my complete environment which I can start managing using this UI, starting with containers. So if I click on those containers, I have these many containers running. I can manage it from here. I can remove the existing container. This is equivalent to using Docker RM, Docker RM -f as well. I can stop a running container by selecting it, or one or more container rather. In fact, I can create or delete all of these from here. Now, when you operate these containers, make sure you don't touch the Portainer because this is actually running inside a container. If you delete that, this application is gone. You can also connect to the existing, to a shell. This is the equivalent to using Docker exec. And I have just used that exec shell. I can select the shell as well, and then connect to the console of a running container. I can also manage or monitor it from here. I can see the information about that container. I can launch a container using that add container utility, where I just provide the name. That is optional. Again, all you have to provide is a name. Let's say I launch a Ghost application using the name Ghost01 and provide the image, which is already there, so it automatically selected it. And I would choose publish all exposed port, which is equivalent to running with capital P. And once I deploy it, that's all it takes. It will just launch it. The image was already there, so it is already running my application. Here I can connect to that. Again, obviously I'll have to replace the IP address with the host's IP that is running my Docker daemon, and I should be able to access the application running there. I can connect to that application again using that shell, and this has a bash shell, so I can, this is like exec. I'm inside the container. I can run any command from here. After I disconnect, I'm going to go back to the container list and show you how to monitor it as well. To monitor it, you can just click on that graph symbol, wait for a few seconds, and it would start generating the data. I'm just fast forwarding it, and it is generating and monitoring the data. It does not store it in a database, so it is just live data that you would see while you have this console open. But that is really useful utility for monitoring the resources, including memory, CPU, etc. You can also manage the images. You can list the images. You can, go and look at the image details, including the size, the commands, environment files, any layers. All of that information is displayed here. I'm going to go and examine the image for my application, that is Ghost. The image for the Ghost application. That's the image for the Ghost application, and I see a lot of environment variables which have been used to build this image, as well as those are the environment variables, and these are the actual layers, and each of that layer has a size, the details. So all of that information is nicely displayed in a tabulated format here on Portainer. Similarly, I can manage networks, volumes. I can look at the volume details here, where it has been mounted and which driver it is using, etc. I can go back and look at the events, which is my Docker system events or Docker daemon events, which are pulled by Portainer. This is equivalent to running Docker system info. That is the engine information. I can also, this is the additional thing that Portainer gives me, is one-click deployment. So this is like a catalog from where I can select the application, and it's going to just launch it with one click. This is the dashboard for Portainer's this endpoint, which is my local instance. Similarly, I can create multiple additional endpoints. I can use the same UI to connect to a remote Docker server as well and add as many Docker instances as needed, and then start monitoring it all from here, this UI. So Portainer is a really useful utility and you should definitely consider using it, especially when you're new. This makes managing containers really, really easy. So far, I've been launching the individual application, and most of these applications had very simple Docker run command. But Docker run, if you look at the help, it has a lot of options. There are like probably around 50 different options, and it can really get daunting if you are start using options for a lot of the way you want to run the application. And so far, especially if it is a multi-container, multi-stack application like this Prometheus, right? So if you look at the Prometheus stack, if you want to launch Prometheus, it doesn't come alone. It has so many different services. It actually has 5 different services, and you will have to remember the run command. If you're launching this complete stack with all these applications, you'll have to remember the run commands, and then those have to be interconnected as well. And that's where Docker Compose becomes really useful, because Docker Compose gives you a way to launch these applications in an automated way. I'm just showing you the example of running a Docker Compose for this Prometheus stack, and this is the Prometheus stack code, and I have a Docker Compose utility here, that Docker Compose.yaml, where the configuration to launch this application, the run commands have been converted into the code. So this is how I launched that container for Prometheus, using an image and the amount of volume, provide the command, define the port, and then many other options. And it's not just one application, there are 4 other applications as well, including Node Exporter. There is Alert Manager, there is Grafana, there is C Advisor. So there are 4 or 5 different applications that it is going to launch, and all of that has been codified. And that's what Docker Compose gives you. Docker Compose gives you an ability to launch this complete stack of services which are interconnected, and it also gives you service discovery, because when these services are launched, they automatically can discover other services as well. And to launch it, all I do is use this Docker Compose utility. I have already downloaded the code which has a Docker Compose file. I'll switch to that directory where the code is and launch that using the complete stack using docker-compose up-d. -d is for detached mode. It automatically uses the INT modes as well, and this reads the Docker Compose utility and launches. So if you look at it, it's just running the Docker run command one at a time for each of that application. So all I had to do was pull that Compose utility and launch it. That's all it takes for me to launch that complete application. Imagine remembering all these options with Docker run and launching it one by one and then connecting it with each other. That will take a really long time, and then I will have to share the instructions with everyone who wants to launch it. Here, I just share that code. That's one Compose file, and it has already launched the application even before I complete describing this to you. And that's the beauty of this Docker Compose, and it has launched the application. It is already running on the respective ports. I'm going to show you 2 of these applications. One of that is Grafana, which is the web interface, and second is the Prometheus UI. So Grafana is running on port 3000. It is already launched with this web application, and if I just log into it and then connect and configure it, it should also start generating the data. So, and in the backend, it is going to use Prometheus. Prometheus also comes with its own UI, and it is already launched. It is already generating the data, so you can choose any of these metrics. And start looking at the graph. It is already running that graph. On the right side of it, you still see the data being generated. It started generating, and that is what Docker Compose does for you. Docker Compose not only makes it easy to launch this stack, but also clean it up. So if you're not installing anything on the system, so you can just run stop to stop all these application at the same time, or just use down to delete it, so it's already gone without a trace. And this is really beautiful, and Docker Compose is a very, very useful utility to automate your development environment setup and the configurations and share it with your teammates. So far, I've been running the containers out of the images which were already pre-created and available on Docker Hub. In this example, I'm going to show you how to create an image out of an application. This is the application code, which is a C application. It's a sample application, but has a UI as well. And I'm going to show you there are a couple of approaches to create an image. In this approach, I'm going to create a container, make manual changes, install this application, and take a snapshot, which will be my image. So the first thing that I do is clone this application from the GitHub repository that I was showing you there. And now I'm launching an application, launching an image with Ubuntu, because this application, the instructions mention Ubuntu as a base operating system. The instructions are given here. The OS is Ubuntu. On top of that, I need to install some build packages, add the source code, and compile it. So I'm using Docker container run -idt, provide a name called as FP. This application runs on port 16,000. That's what I saw in the documentation. So I'm just exposing that port in advance. You cannot change the port mapping later, so it's important to do that in advance. I just launched it with shell, that is bash, and I'm going to connect to it using docker exec -it, the name of the container or the ID of the container, and shell, that is bash. And now that I'm connected here, first thing that I need are the utilities to build that application, which includes make, build essential, etc. So those are the prerequisites which I have to take care of. This uses Ubuntu and it needs these packages. The instructions to install these prerequisites are also given there using apt-get I have already started apt-get update. I'm going to run the docker apt-get install and then start building that application using the make utility. So I'm just running this command without sudo because I'm already root inside that container. And this is going to start running the command to install all the prerequisite application, which includes make, GCC, and the rest of the utilities that I would need to compile a C application. So I just verified that I have the build utilities. Now that I have the build utilities, next thing that I'm gonna need is the source code to build it. So I just exit that. This is where my source code is. I'm outside the container on the host and I'm using Docker CP. You can also use Docker container CP, Facebook as that complete directory inside this container that I created with name FP. I've just copied that inside OPT directory. Now I connected back to the container using exec. And if I switch to opt directory, I already see the source code. I have the source code. I have the build utilities available as well. I can start compiling that application now using this instruction, that is make all. I'm already in the Facebook directory. I just run make all, which is going to compile that. It shows some warning because the code is slightly older, but it's nothing to worry about because it has created the binary which is here. And I'm going to launch it using a relative path from this directory, that is bin Facebook. It's launched on port 16,000. So if I go back to my servers, IP:16,000, this is the application that I see. It's already been launched here. And that's it. So now that I have the application installed, I can just commit the container that I created and updated to an image. This is just like VM when you start a VM, make changes, and then take a snapshot, which becomes your image. So this time around, I noted the container ID and I'm using Docker container commit command. So you can create an image from a container's changes using docker commit. You can also look at the changes using docker diff command. So if you look at docker diff, these are all the changes, including the make, GCC utility, as well as my application which has been installed. If you use docker diff, it shows you the complete diff between the image and the container that you started with. I'm going to commit that container into an image using docker container commit command. And to the commit command, I provide an option, that is container ID and the tag. This is important, and the tag will include your own Docker Hub ID. Don't use the one that you see on the screen. That is important. Don't use initcron. That's my ID. You would have to create your own Docker Hub ID and then use that / Facebook is my repository :v1. If you don't have the repository on Docker Hub, that's fine. It will automatically edit. And commit is a local action. So it has created an image locally. If I list it using Docker image ls, I see that image being created. I can also get the history, which shows me the URL, the layers of that image. and I'm going to push that image to the registry. In order to do that, first I need to log in. So I use Docker login, which will log me into Docker Hub registry. I would use my username that is already created on Docker Hub. If you don't have the user ID on Docker Hub, please make sure you have one before you commit. And now I'm going to push that image using Docker image push command with my tag, which includes the username, that is namespace, repository, and tag. Username / Facebook repository : tag, that is v1. So it's the version 1 of the image that I have, which is been now published to the Docker Hub. And once this is completes, you can go to Docker Hub, go log into your user ID, and you will see that image published available. So I'm already logged in with my user ID, and if I go to the repository Facebook, I see version 1 published just about a minute ago. This is the first approach. In the next approach, we're going to start using the Docker file, which is more programmatic and automatable approach. In the previous lesson, I showed you how to create a Docker image using a manual approach. However, that was a completely manual approach where I had to rely on a bunch of instructions. This time around, these are the instructions that I followed. So you have to look at the instructions, share those instructions for anyone who wants to create that image. This time around, I'm going to start following an automated approach using Docker file. So there is a Docker file. If you look at a branch called as Docker, on the same repository, there is a file by name Docker file. And if you look at the Docker file, it has a bunch of instructions. And if you look at closely observe those instructions, it is something similar to what we did manually as well. But it's part of a code which I can invoke using a command called as docker build, which is much easier, and then I can automate that. So if I go back to my console and run docker, this is what I used earlier, so docker container commit. Instead of that, I'm going to use an image build process which reads a Docker file, and that is provided as an input to this command docker image build. And you can provide many options here, including the file name. If you have a file by name docker file with D capital, that's a default. And I'm going to pull that branch going to the repository. I'm already in the repository. I'm checking out the branch or pulling the branch using get checkout docker. Docker is the name of the branch. And the moment I do that, I see the Docker file available now. And it's the same Docker file that I showed you earlier. I'm going to start a Docker build process here. So Docker image build rather. You can use Docker build or Docker image build interchangeably. To this, you provide an option that is tag. Tag is again similar to what we added earlier. Username / repository : the version. So this time I'm going to use a version number 2. And that's where you provide your user ID, not mine. Make sure you use your user ID in the namespace when you provide the tag. And then you have to provide the context, which is the dot where the Docker file is. That is really important as well. So don't miss that dot at the end. So it started reading the Docker file, and accordingly, it is automatically this time creating the build. It launches containers, intermediate containers on its own, and runs all these instructions, copies the source code, compiles it, adds the port, everything that I did manually earlier is now been automated. And you see a bunch of intermediate containers being created there. And if you run it again uses cache. So this is even more efficient because all the subsequent changes at times, unless you change things, it will not execute those again. I have 2 images now, version 1 and version 2. I have built one with Docker file, another using a manual approach. Let's look at the difference between the layers those two have created. I'm using Docker image history command and the image IDs. This one has about 6 layers that it has generated versus the version 1 of my image. You can look at the timestamp created time, and it shows you what layers have been generated recently. My first image has only 1 layer versus the second image gives me a nice history, and it also gives me an ability to provide ports to expose, command to define, which make launching the container easier with default options. So if I want to launch it, I can just use this docker container run -idt-P, the image name, and it just goes ahead and launches that application. It has read the exposed port, mapped it to some port here, which I can use to access that application. My application is ready, and that's the UI for Facebook. Yeah, it's the best social network you have never heard of. Funny, but it's a very simple application, and it's a very nice application to try out your Docker build process. And I'm going to publish that image to Docker Hub again. You can also tag it as latest. Let's say that is explicit tag, so you can use Docker image tag command and point your latest to, let's say, this version 2. And by the end of this, I should have an image published on Docker Hub. So what I've showed you is two approaches. One is the manual approach, second is with Dockerfile. Dockerfile is definitely a recommended approach, and it gives you an ability to automate the process of building it, as well as, since you can store it as a source code, you can share it with others. And I have the version 2 of my image just published there. In this video, I'm going to give you a quick primer and explain the Docker file that we have used so far. On the left hand side, you see the Docker file with all these instructions. On the right hand side is the explanation. Right from what is Dockerfile. Dockerfile again is a text configuration which you can share, you can recreate, you can since you have revision controlled it as Git, you can also have this shared and automatically build the same image. Now these are the main instructions, and we're gonna look at the instructions on the left hand side and try to understand what each of these do. Starting with from. Now from is where we define which base image that we want to use to launch a container to build this image from, and that accepts all the 4 fields that an image can take. Right now it is just a repository, but you can also provide tag, registry, as well as the namespace. The next is a run command. Run is a core of Dockerfile, and this is where we define what to do. So if you remember, I installed these applications manually earlier. In this case, Docker build automatically launches a build container. Inside that, it is going to run all these instructions, including apt-get update, install, etc. So layering is another important concept that you need to understand, and each of this instruction, almost everything except for from, is going to convert into a layer. So if you look at the layers using Docker image history, you will find out that it has about 6 layers created for that image, and that corresponds to the number of instructions that I have. So if you look at this, it's each instruction which is converting into a layer. Except for from, I have 6 instructions, and each of that 6 instruction is converted into a layer. Now there is a limit on the number of layers, so you need to be aware of how to optimize these layers and combine those run instructions using either and or using semicolons. Command is something that you define which needs to be launched at the runtime. After you create an image and when you run an application or container using that image, what application to launch, that is the command. So you don't have to go and specify bin Facebook every time. It would automatically use that command because it's been provided as part of that image build instruction, which sets the metadata. That's command. Port is the application port that you want to expose on, and when you use capital P, it automatically reads the port that you have exposed, that is 16,000, and maps it to an available unused port. In this case, it's 32773. So that port mapping depends on what you put in expose instruction right here. You can also provide environment variables, add the files or copy it. Add and copy are quite similar. We are using copy here. So copy will copy from the build context. Build context is the current directory. So when you use Docker build command, whatever you provided as a build context at the end, in this case, it's current directory. All of this gets copied to the containers opt Facebook to build it, and then you run make all instructions, expose, and so on and so forth. There's also a concept of work directory, so everything that you do in the build container runs from the work directory. In fact, even if you launch a container and connect to that, you will land up in the work directory. That serves as a present working directory for every single instruction, including command, run, build, everything. So it's opt Facebook is what I landed inside, and from here I have run that bin Facebook runs from that work directory. So everything runs with respect to the work directory. That was a very quick dive into the Docker file, mainly to explain the Docker file that we have used in the previous lesson to generate the image. I hope you enjoyed this series so far, and I hope you now are able to run containers, build images, use Docker Compose, and this is the quickest way to run any application, and this is the easiest way to run it as well. Now, that knowledge should be enough for you to get started with Docker. Now, where do you go from here on is, if you want to understand and learn Docker in depth, we have a comprehensive course related to Docker. So if you're considering learning Docker, you should definitely sign up for that, and we're gonna give you a special offer along with this video. So along with this video, you should find a special offer or a link to the special offer. If you're interested in learning Docker, definitely consider it. I hope you enjoyed this series and happy learning.